Let's talk about lipids now. Now, as I said previously, lipids are oils and fats. So, what's the difference between an oil and a fat? Well, at room temperature, oils are liquid and fats aren't. So, examples of your fats are going to be your butters and your margarines and things like your shortenings and your lard. And I just put on here a couple of old ads from the 1950s. They're young, they're in love, they eat lard. Well, that might have been great post World War II, but nowadays we know that lard is really not good for you. So, you know, a happy young family is not going to be one that's advertising how much lard they are eating. All right, but let's move on and let's talk about lipids. So when we're talking about lipids, let's talk about triglycerides because this is going to be a really common form of lipid we are talking about. And so if we look at the word triglycerides, we can see that prefix tri, and then we can see glyceride. And so what that means is it has three of something and something that's related to glycer. So what it has one glycerol and three fatty acids. But first off, when we look at this, so basically all of our lipids, the building components are going to be fatty acids. So just like the building components of all carbohydrates were sugars, the building components of all the lipids are going to be fatty acids. Okay. And triglycerides are not polar, meaning there's no part of it that's positively charged and no part of it that's negatively charged. They don't want to form bonds with other molecules. And because of that, they're not going to be attracted to water, meaning they are hydrophobic. Because remember, water's got a side that is positive and a side that is negative. Okay. So looking closer at the structure of a triglyceride, here is the glycerol molecule, and a fatty acid basically is just a long chain of carbon molecules with the attached hydrogen to it. And at the end, it ends with a C, a oxygen attached with a double bond, and then a hydroxyl at one end. Okay. And there are going to be side chains attached to that COOH, and those different side chains determine which triglyceride it is. Beyond the scope for this class to talk about different types of triglycerides. However, I do want to talk about phospholipids. So let's look at this word. We have a phospho and a lipid. So we know it's going to be a lipid, but it also has a phosphate attached to it. And here is what phosphate is. It's a phosphorus with 4 oxygens, and it has a negative charge to it. So what has happened is we have taken our glycerol, which was not polar, and where one of the hydrogens was, we attached a phosphate which is negatively charged. And so now a polar group can attach to it. So we've got these little water molecules that can attach to the phosphate if we want. And so what it has done is it has made the glycerol phosphate end, has made this end what we call the head of the phospholipid. It has made it hydrophilic, and where the fatty acid chains are, this is called the tails, that part is hydrophobic and non-polar. Okay, so I don't expect you to be able to draw that. So the way we draw that, even this, we simplify it to a head with 2 legs. We make it stick figures, okay? So if we were to take a handful of these phospholipids with the hydrophobic heads and with the hydrophobic tails and the hydrophilic heads, and we were to dump them into a container of water, they would spontaneously arrange themselves like this. They would form what we call a phospholipid bilayer. Bilayer meaning two layers, where their heads are on the outside because their heads are hydrophilic. They love water. So there's going to be water on this side, there's going to be water on that side. And then their tails are protected on the inside where they don't love water. Okay. So this is what it would look like. They would form like a little circle. So you could have a watery environment here on the inside next to the hydrophilic heads, and you could have a watery environment here on the outside next to the hydrophilic heads. And here in the middle, where you had the hydrophobic tails, would be a non-watery environment. And if we looked at it through a scanning electron microscope, between two cells is exactly what it would look like. Here is cell 1 with its phospholipid bilayer. The head's there and the head's there and the tail's there in the middle. This is between the two cells. Whoops. And then here's the phospholipid bilayer of the adjacent cell. So this is what happens in your body. Kind of a cool thing. All right, so what happens though when we have something watery with something lipid based? Well, that's what salad dressing is. So think about the last time you took a bottle of salad dressing off the shelf, oil and vinegar. Vinegar is water based. It was separated. So what did you do before you put it on your salad? You shook it up. When you shook it up, what you were taking was that big blob of oil and making tinier and tinier little bubbles out of it. So you were doing a mechanical digestion, not a chemical digestion, a mechanical digestion of those bubbles, making them smaller and smaller and smaller. And that process was called emulsification. It's the same thing you do when you put laundry detergent in to get oily and greasy stains off your clothing, or you do dish detergent when you're washing your dishes. Okay. So what is, if you look at the surface here on the dish, what you would see is you would have oil globules surrounded with little lipid layers going on. It's also the exact same process by which mayonnaise is made, or Miracle Whip. Oil and water and egg. So basically to make mayonnaise, they put water and egg in a bowl, and you mix it up while you drizzle in oil very slowly so you can make it emulsified. Science at work in your house all the time without you realizing it. All right, so let's get back to lipids. Let's talk about fats. And we've all heard about saturated fats and unsaturated fats, and what does that mean? So when a fat is saturated, what that means is every carbon has 4 bonds. Okay. So look, every one of these carbons has a single bond. It is maximally saturated. This is going to be solid at room temperature. If it's unsaturated, it means we are going to have at least one double bond. And what that means is there's going to be a bend in the structure. This is going to give it liquidity, movement at room temperature. So unsaturated fatty acids are our good fats, and saturated fatty acids are our bad fats. So to look at that a little bit more closely at our dietary fats, our monounsaturated fatty acids are our best ones. Olive oil, canola oil, those are your best ones. And our saturated fatty acids are our worst. And I know all of you are telling us, no, coconut oil is good for you. Well, it may be one of the best of the saturated ones because, yes, most of our saturated fats are animal fats. And coconut fat is better for you than, for instance, lard or beef tallow, but it's nowhere good for you. So kind of get that out of your mind. And I think by now we all know trans fats are bad for you. And I will show you what a trans fat is on the next slide. So remember, unsaturated fats are all going to be liquid at room temperature. The reason why they're good for you are because they increase your good cholesterol, which actually takes bad cholesterol out of your blood and removes it from your body. Whereas saturated fats increase your bad cholesterol, which clogs your arteries, gives you atherosclerosis, hardening of the arteries, leads to heart attacks and strokes. Does that mean you can never have a steak or never have butter? You can, in moderation. If you want butter, use it when you want the butter taste, like on a piece of bread. Okay. All right. So think about the little pyramid when it comes to fats. Mono unsaturated fats. Be cooking with olive oil. Olive oil can be expensive. Use canola oil. So unless you want the taste of olives, use canola oil. Avoid trans fats. Don't use them. Try not to consume them. Okay. They're banned in a lot of European countries. A lot of American foods that contain trans fats the same food in Europe does not contain the trans fats because the European countries have outlawed them. Okay. Cut down on the saturated fats. All right. So what does trans fats have to do with it? Well, basically what happens is if you take an unsaturated fatty acid and you hydrogenate it, you add hydrogen molecules to this. In nature, hydrogen is only added to one side and you get what we call a cis fatty acid. This is how it occurs in nature. So in other words, trans fats do not occur in nature. That should be a clue as to why they're not good for you. Okay. So notice we broke this one double bond and the two hydrogens appeared on the same side. So in a trans fat, when we broke that bond, the two hydrogens were on opposite sides. That's the trans fat. Here are the foods that contain trans fats. Okay, well, I'm like you, we all are going to eat pizza and potato chips and burgers. The point is moderation. Doesn't have to be Wagyu beef. Doesn't have to be Prince Street loaded with pepperoni. Doesn't have to be twice a day, every day. Think about what you're consuming. Okay. And if you can, stop and read about what these trans fats are doing to your body, because we used to not worry so much about hardening of the arteries, atherosclerosis, until you were in your 40s, your 50s, and your 60s. But now the amount of disease that we would find in people in their 50s and their 60s, we now are finding in college age students. And that is because of the diet you are eating in middle school and high school and in grade school. So you need to change your diets today. Just say. All right. The last thing about lipids is steroids are lipids. Okay. They are lipids in a ring shape. Steroids are 4 carbon rings. Notice 3 of them are 6-sided, and then there is a pentamer. So these 4 rings are all fused together, and that's a carbon ring. And steroids are made out of cholesterol. Okay. And cholesterol, yeah. Animal products, high source of cholesterol. Your body makes enough, you don't have to consume it. But cholesterol is going to be used for your body to make cortisol and all of its sex steroids, whether it's progesterone, testosterone, estrogens, or things that have to do with your salt balance we'll talk about later in this course. And with that, I am done with the lipid macromolecule. So I'll see you soon as we return back to talk about proteins. Thank you so much.